Welcome, dear students. Myself, Dr. Rajeshri Dua, Assistant Professor, EEE Department. And today I am going to discuss about Unit 3, that is energy storage, of the topic electrical and hybrid vehicle, which is an elective subject with the subject code PEEE 602A. Now, basically, for a hybrid vehicle or a electric vehicle, the main contenders for energy storage or power sources are the chemical batteries, the ultra capacitors and the supercapacitors, and the ultra high speed 5 wheels, and the fuel cell. Coming to first, the electrochemical batteries. So, the electrochemical batteries, most commonly referred to as batteries, are electrochemical devices that convert the electrical energy into potential chemical energy during charging, and they convert the stored chemical energy back to electrical energy during discharging. A battery is composed of several cells that are stacked together. A cell is an independent and a complete unit that possesses all the electrochemical properties of a batteries. Basically, a battery cell consists of the three primary elements, the two electrodes, the positive and the negative, and the electrolyte. And the batteries are basically having the unit of ampere hour or watt hour. Now, a very important parameter of a battery is known as SOC. So, SOC is nothing but state of charge. It is defined as the ratio of the remaining capacity of the battery to the fully charged capacity. With this definition, a fully charged battery has a SOC of 100% and a fully discharged battery has a SOC of 0%. However, the term fully discharged sometimes causes confusion. So, a change in SOC can be referred to this equation, and Qi is the ampere hour capacity of the battery at current rate I. For discharging, I is positive, and for charging, I is negative. So we can see this SOC in this format, where SOC 0 is the initial value of SOC. For EVs and HEVs, the energy capacity is considered to be more important than the coulometric capacity, that is the ampere hour capacity, because it is directly associated with the vehicle operation. The energy delivered from the battery can be expressed as this, which is also a function of the voltage and the SOC, where VISOC is the voltage at the battery terminals, which is a function of the battery current, and SOC. So, how healthy a battery is determined by SOC, that is the state of charge. Now, there are certain electrochemical reactions that go on inside the battery, and for understanding the electrochemical reactions, we have taken into consideration a lead acid batteries discharging and charging cycle. Because this lead acid battery was the most simple and most widely spread battery technology. So what we do is that a lead acid battery, it basically uses an aqueous solution of sulfuric acid as the electrolyte. The electrodes are made up of porous lead, that is the lead anode, electrically negative, and porous lead oxide, that is cathode, which is electrically positive. The processes taking place during discharging are shown, where lead is consumed and lead sulfate is formed. So Pb plus SO4 2 minus, that is PbSO4 plus 2 electrons. So this reaction basically releases 2 electrons and gives rise to excessive negative charge. And another kind of reaction also goes on like this. So what we do is that during charging, the reactions of the anode and cathode are basically reversed. So here the anode, what it does, the lead acetate plus 2 electrons, they convert to lead and SO4 2 minus. In the cathode, the lead sulfate and the water, they give rise to lead oxide, the hydrogens, the SO4 2 minus and 2 electrons. So the overall reactions charge discharge can be given by this equation: lead plus lead oxide plus sulfuric acid for charge discharge will give rise to lead sulfate plus water. A lead acetate battery has a cell voltage of 2.03 volts as standard condition, which can be affected by the concentration of the electrolyte. Coming to another important term for batteries, that is the specific energy. So specific energy is defined as the energy capacity per unit battery weight, and the unit is watt hour per kg. So this is a basic typical equation. Now coming to specific power is defined as the maximum power per unit battery weight that the battery can produce in a short period. So it will be watt per kg. Specific power is very important in the reduction of the battery weight, especially in high power demand applications such as hybrid electric vehicles. So this is basically a battery model. So there's a internal resistance, the load resistance, and it is the conductor resistance RC, and we get this kind of equations from the normal battery circuit model. Now, coming to another important term of batteries, that is energy efficiency. The energy or power losses during battery discharging and charging appear in the form of voltage loss. Thus, the efficiency of the battery during discharging and charging can be defined at any operating point as the ratio of the cell operating voltage to the thermodynamic voltage of the battery. So, this is the equation for discharging, this is the equation for charging, and this is the typical variation of efficiency versus SOC for a battery cell. And the terminal voltage is a function of battery current and energy stored in it, or the SOC is lower in discharging and higher in charging. And figure 6 basically shows that the efficiency of the lead acid battery during discharging and charging. The battery has a high discharging efficiency with high SOC and a high charging efficiency with low SOC. The net cycle efficiency has a maximum value in the middle range of SOC. Therefore, one can say that the battery operation control unit of the HEV should control the battery SOC in the middle range so as to enhance the operating efficiency and decrease the temperature rise caused by energy loss, because high temperature leads to thermal runaway and damage of the batteries. So, what are the typical battery technologies that we use? Obviously, we have discussed about the lead acid battery. Then we have nickel based batteries like nickel ion, nickel cadmium, and nickel metal hydride, and lithium based batteries like lithium polyam and lithium ion, which are very popular. It seems that cadmium based and lithium based batteries are the major candidates for future EVs and HEVs.